Okay, so today I'm going to be going through the entire GCSE Maths paper for November of 2018. This is the foundation paper and it's paper 1, so it's non-calculator. I'm going to be going through every single GCSE past paper there's been, hopefully releasing one a week, and this is going to be the first one. Like I said, November 2018, paper 1, non-calculator, and it's foundation tier. So for the first question, question 1, we need to work out what -3 plus -8 is. So the key thing in this question is to know that when we've got a negative number plus another negative number, what happens is these two signs here, the plus and the minus, overall we get a minus. So this question is actually, what is -3 take away 8? And the answer is, of course, -11. So we just have to circle -11. So moving on to question 2, we need to answer, what does the longest bar in a bar chart represent? And we need to circle the answer. So if we consider a bar chart, what we've got is I'll just quickly sketch one. So we've got our axis here, and then we've got numbers going up the side, so the amount of times a piece of data occurs, and then we've got bars here. So let's draw one that's larger. Let's say we've got one here. Of course, this is not drawn to scale. And the question asks us, what does the longest bar in a bar chart represent? And it's either the mean, median, mode, or range. Okay, so the longest bar is, of course, this one here, and each of these columns represents a piece of data. So let's say how many cats were spotted in a day, how many dogs were spotted, and how many owls were spotted, I don't know. Okay, and we can see that this column here is the largest because it's got the most number of dogs spotted in a day, and this number is actually the mode, because this is the data value, dogs, that occurs the most frequently at roughly 5 times, whereas the others are less. So the answer is the mode. So for question 3, we need to work out what 1.1 take away 0.15 is. So this is a fairly straightforward calculation. I'll try to break it down in case you find this a bit difficult. So what we've got is 1.1, and then we can say we've got take away. We can break this down into 0.1 and then plus 0.05. So then take away 0.1, take away 0.05. We can then do this part first. So this gives us 1, take away 0.05, and then this is equal to 0.95. So the answer is the first one. Okay, so question 4, we are asked, on a circle, which of these is always longer than the diameter? And we need to circle our answer. So the best thing to do is always to draw a quick diagram. So let me quickly draw a circle. That's not a circle. Yeah, there we go, that's a bit better. Okay, so let's label all of these things on our circle, and then we can work out the answer to the question. So the circumference is obviously the entire way around the circle, so I'll call this C. Then an arc on a circle is, let's say we've got this length here, we'll call this A. Radius is from the edge to the middle, so that's R. And then a chord is cutting across a section of the circle, so we can then say this is a CH, we'll call it chord. And the question is, which of these is always longer than the diameter? So straight away by looking, let me just quickly label diameter as well. So diameter it should be on the same line as the radius. This is diameter, and then let me quickly just do that for radius. Okay, so we can see that the radius is not longer than the diameter, so we can immediately discount that one. A chord doesn't necessarily have to be longer than the diameter. The only way it would be equal to if it was actually the diameter itself, because every other length along the circle, whether it be a tiny chord like that or whether it be a big one like this, it will always be the very most equal to the diameter, if not less. And then an arc, again, you know, this could be more than the diameter. If we did a big arc like so, that's probably more, but we could have a little arc like this. So the answer that we're left with is circumference, and if we consider it, we can actually write down the formula for circumference. So the circumference, C, is equal to pi times the diameter, D, where pi is equal to 3.14. So we're multiplying D by 3.14, so it's always going to be bigger. The circumference is always going to be bigger than the diameter because of this. And just from observation, we can see the circumference of any circle is going to be bigger than the diameter. So a bit of a long way to get there, but I hope the explanation was useful. The answer is circumference. Next question, we need to work out what 83 times 26 is. An easy way to do this, I find, it may take slightly longer than just doing this calculation straight away. But what I like to do is we can break 83 down into 80, and then we've got a 3 as well, and we can break 26 down to 20 and then 6. So we make a little table, we put 80, 3, and then we put our 20 and 6. We can then draw a box like so, and then we basically work out what 80 times 20 is, what 80 times 6 is, and then 3 times 20 and then 3 times 6. So 80 times 20 will give us 1600. 80 times 6 is 480. 80 times, not 80, sorry, 3 times 20 gives us 60. And 3 times 6 gives us 18. And then what we do is we add all these up, so 1600 plus 480 plus 60 and then plus 18. So if we do the first two numbers first, we get 2080 plus 60, 2140, and then plus 18, we get 2158. Okay, so we are told we've got 3 calendars and the cost is £18, and we need to work out the cost of 5 calendars. Okay, so let's get the key bits of information. 3 is £18, so to work out the cost of 1 calendar we do 18 and then we do divided by 3 to get £6, and then we need to work out the cost of 5 of these calendars, so we simply do 5 multiplied by the cost of our 1 calendar, which is 6, and this is equal to 30, so the answer is £30. Okay, so for question 7, we are told that we've got a helicopter blade and it does 3,206 full turns in 7 minutes, and we need to work out the number of full turns per minute. Okay, so what we essentially need to do is divide the amount of full turns in 7 minutes divided by 7, so then we get the amount of turns in 1 minute. So what we do is 3,206 and then divided by 7, so we're going to use the bus stop method here. So if we draw a little line above and then one vertically, I'm going to put a 7 here to show what we are dividing by. It's probably useful to do this in the exam just to make it absolutely clear what you're doing. Just do this, 3,206 divided by 7, just so that the examiner is absolutely certain about what you're doing here. So then what we do is we consider 3 and 7 and ask, right, can we divide 3 by 7 to get a whole number? The answer is no, so we just put a 0 there. We then carry the 3 over to the 2, just put a 3 up here. We then consider 32 and 7, so can 32 be divided by 7 to get a whole number? It can't be divided to get a whole number exactly, but we can go to the nearest whole number that 7 multiplies by. So 7 times 4 gives us 28, so we've got 4 wholes, and then 32 take away 28 leaves us with a remainder of 4. Okay, we do the same thing then. 40 and 7. 40 and 7, we can't divide 40 by 7 exactly, but we can go to the closest number, which is 7 times 5, which gives us 35. So we can put a 5 down here, and then 40, take away our 35, leaves us with a remainder of 5, and then we consider 56 divided by 7, and this does divide exactly, so 56 divided by 7 gives us 8, so the answer is 458. Just one quick thing, when I say we go to the closest number, that say 40, that 7 times something gives to get 40, the closest number in this case is actually 42, because 7 times 6 equals 42, but as this has exceeded the value here, we can't exceed this value, so we have to go to the closest number that is below 40, which is 7 times 5, which equals 35, and then our 40, take away our 35, leaves us with a remainder of 5 up here. So that's how you do that question. Okay, so question 8, it looks like a probability question, so let's take a look. At a cinema, films are shown on screens 1 and 2. Customers pay full price or child price, so there's 2 different prices. There are 3 times as many customers in screen 2 as screen 1, and 68 customers paid child price, and we need to complete the frequency table. So this is our table down here. Okay, so the key bit to information is that 3 times as many customers in screen 2 as screen 1, so I'll just say 3 times screen 2, okay, and then what else? 68 customers paid child price, okay, so 68 child. So then we just need to complete our table using this information. So we are told in this branch here how many people are at screen 1, and that is 87, but there are 3 times as many at screen 2. So to work out what this value is here, what we do is change colour. We're going to do 3 multiplied by our 87, which is equal to 261. So this value here is 261. The way I did this in my head was 3 times 80, which is 240, plus 3 times 7, which is 21. Add them together, you get 261. So we've completed that part. We then can work out what this part here is, because we've got both the branches, and we simply just have to add these together. So to work out this branch here, what we do is 87 plus 261, and this is equal to, let's see, plus 7 to 261, we get 268, plus 80, we get 348. So in total there are 348 people. Okay, moving on to, okay, what have we got now? We've got 15 children here, but we know the total amount of children is 68. So to work out the other child spot, which is this one, we do 68, the total amount of children tickets, take away the 15, which we already have. That's a terrible 5, let me redo that. Take away, Jesus Christ, take away 15, there we go. And this gives us, let's see, take away 10, we get 58, take away another 5, we get 53. So this box here is 53. What we can then do is work out the 2 remaining parts of our frequency tree, because we know the total amount, 261, is equal to this section plus this section. So to work out this one, what we do is 261 take away 53, and this is equal to 208. So this goes in this one here, and then we do the same method up here. So 87 is equal to 15 plus something. So to work out our final section, we do 87, and then we take away the 15 we already know, and this leaves us with 72. So this is the final one, which is 72. So it might seem like a, I don't know, maybe a slightly confusing question, but you just got to get the information and then just work out what you can as we go along. And this is, you know, the maths is fairly straightforward. It's just knowing which section to do first and so on. Question 9, we need to work out the fraction that is halfway between a half and 1 1/4. Okay, so they've given us a number line here. I don't know if you have to use it. I mean, it doesn't say to use it specifically, but we'll use it anyway just for this example. So let's label on our 1/2. So we've got 1 here, 0 here, and then we've got 1, 2, 3, 4 intervals. So each interval is worth 0.25. So to get a half, we move along 2. So this is our 1/2 here. Okay, 1 1/4 is each interval is worth 0.25. 1 1/4 is simply just here. So to work out the fraction that's halfway between a half and 1 1/4 using this number line. We count the intervals between our two values here. So we've got 1, 2, 3 intervals. Okay, so therefore 3 divided by 2 to find the halfway point gives us 1.5. So we move along 1.5. So this is the value that's halfway. Just mark it on. This is it here. So this is 3/4. This is 1. So in the middle of these two values, what we've got is 7/8. Because, I mean, this number line actually confuses the question, to be perfectly honest. But we can say this is 3/4 and this is 1. So what we can then do is 1 take away 3/4, which is equal to 1/4, and then 1/4 divided by 2 to find the middle point. So divide by 2, we get 1/8. And then if we take 1/8 away from 1 to go backwards, that little part, what we get is 1/8. Sorry, the wrong way around. 1 take away 1/8, we are left with 7/8. So the answer is 7/8. So question 10, we are told that we've got an integer which is called x, and it is a positive integer. 35 divided by our positive integer x also gives a positive integer, and we need to work out the 4 possible values of x. Okay, so basically 35 divided by some whole number will also give us some whole number, some positive whole number. So what can we divide 35 by to get an exact number? So we can divide 35 by 1 to get 35, that works. We can divide 35 by 7, that also works. Likewise, we can divide 35 by 5 to get a 7, that works. And finally, we can divide 35 by itself, 35, to get 1. So therefore our 4 numbers are the ones we've divided by. So we've divided by 1, 7, 5 and 35. So these are the values for this question. Might sound like a bit of a confusing question, the way they've described it, positive integers divided by x and so on, but all we've got to do basically is find out what numbers can we divide 35 by to leave us with whole numbers, and yeah, the answers are 1, 7, 5 and 35. So for question 11, we've got some information. We are told a fair dice has got 6 sides, numbers 1 to 6, and after it is rolled, 5 of the numbers can be seen. So for part A, we need to write down the probability that one of these 5 numbers is a 2. So let's consider this. The only way that we wouldn't be able to see a 2 on any of the sides is if the 2 is face down on the surface of the table, because then obviously we can't see it. If the 2 is in any other position, we can see it. So the amount of times that we can't see a 2 is equal to 1/6. So no 2 is equal to 1/6, because, like I said, this can only happen when the 2 is face down on the table, and as there are 6 sides to a dice, this can only happen for one of the sides, so 1 in 6. So therefore, the probability that one of these 5 numbers is a 2, so one of the numbers that we can see, is going to be equal to 1 take away the probability that we can't see a 2, which is 1/6. So the probability is equal to 5/6, and that's the answer for this question. So for 11b, we are then told that we need to work out the greatest possible sum of the 5 numbers. So this is referring to the 5 numbers that we can see on the dice. So a way to think about this is, what is the lowest number on a dice? And of course it's 1. So the lowest number when it's hidden, as in when it's face down on the surface, will give us the highest total of the rest of the faces that we can see. So if the 1's face down, we are left with a 2, a 3, a 4, a 5 and a 6. So all we have to do is add all these up. And when we do that, we get 2 plus 3 is 5, plus 4 is 9, plus 5 is 14, plus 6 is equal to 20. So the greatest possible sum of the 5 numbers that we can see is equal to 20. Question 12, we need to work out the value of 2/7 plus 6 over 7. Okay, so as the denominator, the bottom number on the fraction, is the same, all we have to do is simply add our two numerators together, and this gets 8. We keep the denominator the same, so 8 over 7. Is that answer there? It is not. Okay, so let's convert 8 over 7 to a mixed number. So as we can see, we've definitely got one whole, as 8 is greater than 7. And then we've also got one remainder from doing our one whole, which is 7, and then 8, take away our 7, leaves us with 1. So this is the mixed number version, and we can see that is there, so the answer is 1 and 1/7. So for this question, if you get 8 over 7 and think, oh dear, it's not there, don't panic, just convert your number to a mixed number, and you know, that number is there in this case. But in any example, if you get a question like this, always consider, okay, if I convert to a mixed number, as we've done here, is that one of the answers? And in this case it was, so yeah, there we go, that's the answer for that question. So we're on question 13 now, and we need to work out the value of 4 plus 3 times 5 take away 1. So this is a BIDMAS question. Some of you may know it as, I think PEDMAS is the one taught in America, or BODMAS sometimes it's taught in the UK. So basically, let me just write it down, BIDMAS. We just need to do our order of operations in the question, in this order, brackets, indices, division, multiplication, addition and subtraction. So the first thing we do is any brackets, we don't have any. So then we do any indices, again we don't have any. Then we do any division, we don't have any. So then we do any multiplication, which we do. So we do this part here first. So this leaves us with, I'll do it here. So this leaves us with 4 plus 5 times 3, which is 15. Take away 1. We then do any addition. Okay, so let's do 4 plus 15, which is 19. Then we've got take away 1, which is equal to 18. So the answer for this question is 18. So question 14, we are moving on to the nth term. So we are told that the nth term of a sequence is equal to 5n minus 2, and we need to work out what the third term is. So essentially all we need to do is wherever we see an n, we just need to replace that with the number 3. So this becomes 5 multiplied by 3, and then we've got take away 2, so this is 15, take away 2, which is equal to 13. So the answer is 13. Okay, so for question 15, we've got a trapezium ABCE. So ABCE, that's our trapezium. And then it's made from a parallelogram, ABCD. So ABCD is a parallelogram and an isosceles triangle, ADE. Okay, so we need to work out the size of angle AED, which is this angle here, AED. The way to label angles, such as AD by the way, is you start where A is here, then you go to E, then you go to D, and it's the angle between these points, so here, that angle. Just in case you didn't know how to do that. So, if we look at our diagram, the only piece of information that we've got on the diagram itself is 110 degrees. So, this is a good indication that we need to use this value first. So remember, we've got a parallelogram, which is ABCD, and a rule for a parallelogram is that opposite angles are equal to each other. So 110 is equal to this angle here, and likewise angle here is equal to this angle here. So we can label this as 110 degrees. And then the next thing to notice is we've got a straight line here, and we know one of the angles on our straight line, so we can work out the remaining angle. So in our straight line we have 180 degrees, and if we take away 110 we are left with 70 degrees. So this angle here is 70 degrees. We are then told we've got an isosceles triangle, ADE, and the rule for an isosceles triangle is that the two bottom angles, so these angles here and here, the two angles at the base of the triangle are always equal to each other. So this angle here is also 70 degrees. We then know that there's 180 degrees in a triangle, so we do 180, take away our two 70s that we already know to leave us with 40. So therefore we have worked out that angle AD is equal to 40 degrees. Okay, so for question 16, we need to work out how many times bigger B is than C. And we've got two ratios here. We've got A to B is 1 to 6, and we've got A to C is 3 to 1. So essentially, what we need to do is to get A to be the same value in both of these ratios, okay? So to do that, what we can do is we can multiply the top ratio by 3. So when we do that, we get A to B is now equal to 3 to 18, okay? And as A is equal to 3 in the second ratio, we can now equate all three letters together, so we can have A to B to C, where A is 3, B is from the top one, B is 18 when we've multiplied by 3 down here, and then C is 1. So from this we can see that B, the ratio of B to C, is here, and B is 18 times bigger than C. Question 17, part A, we are told that Laura wants to work out what 3% of 1700 is, and her method is 1700 multiplied by 0.3. Is her method correct? And we've got to say yes or no and then give a reason. So if we consider the number she's multiplied by, which is 0.3, this is not correct, because if we were to multiply by 0.1, this is equal to finding 10%. So 0.3 is equal to finding 30%. So she'd have to multiply by 0.03 to find 3%. So the answer is no, and a reason, I'd say something like I'd put to find 3%, she has to multiply 1700 by 0.03, and that should be enough for the 1 mark, definitely enough. So for part B, we are told that Laura also wants to work out what 30 over 29 over 60 is. Her answer is 58. Is she correct again? And we need to tick a box and give a reason. I mean, straight away we can see that 30 over 29 here, that is greater than 1. So the answer is going to be greater than 60. And she's got a 58, so we can say straight away that she's wrong. And a reason, we could give something as simple as 30 over 29 is greater than 1. Therefore, 60 multiplied by 30 over 29 must be greater than 60. And that's again enough for the 1 mark. Question 18, we are given 5 shapes which are labelled A to E in this table here, and we've got a Venn diagram, and okay, so basically what we need to do is complete the Venn diagram with the letters for A to E. Okay, so I believe this is called epsilon, I think it's epsilon, and that is the set of all shapes. Okay, so all the shapes are going to be somewhere in this Venn diagram. We've then got Q, which is the set of quadrilaterals, and R is the set of shapes which always have rotational symmetry. So that means that any quadrilateral goes in Q, and if there's any shapes which always have rotational symmetry, they go in R, and if they are already a quadrilateral, they go in this middle part here. And any that don't fit either of these 2 points go on the outside. So let's see. Let's first of all say if each of these shapes is a quadrilateral. So parallelogram has 4 sides, pentagon is not, rhombus is, triangle's not, trapezium is. Okay. Now let's go through and see which of these always have rotational symmetry. So a parallelogram, Okay, so a parallelogram does have rotational symmetry, because if we consider it, I'll just sketch it really roughly. Something like this, we can rotate it 180 degrees and we'll end up with the same shape. So a parallelogram is. A pentagon, of course, as its regular is, we can rotate it clockwise or anti-clockwise and we'll get the same shape. A rhombus, let's consider a rhombus, so it's essentially a diamond. And again, we can rotate 180 degrees and we get the same shape, so a rhombus does. A scalene triangle doesn't, because it's got no symmetry. And a trapezium, again, if we consider a standard trapezium, something like this, we can't rotate this apart from 360 degrees, which is a full turn, to get the same shape, so a trapezium doesn't. So if we fill out our Venn diagram, parallelogram is yes to both, so it goes in the middle, so A goes in the middle. Then regular pentagon is no and yes, so it's no to Q, yes to R, so B goes in here. Rhombus is yes to both, so C goes in the middle. Scalene triangle is no to both, so D goes on the outside somewhere. Doesn't matter where you put D, just somewhere on the outside. But make sure it's within the square. When I say on the outside, I mean within the square, but outside of the two circles. And then trapezium. It's yes to quadrilateral and no to symmetry, so trapezium, which is, what letter is that? E, goes in this box here, and that is the question complete for 3 marks. So question 19 is algebra, so we've got a equals 7, b equals 2, and we need to work out the value of a over b, take away a to the power of b. So wherever we see an a in this expression here, we replace it with a 7, and wherever we see a b in this expression, we replace it with a 2. So we've got 7 over 2, and then we've got take away 7 to the power of 2. So let's work out 7 to the power of 2 first. So 7 over 2 stays the same, and then 7 to the power of 2 is 49, so take away 49. We then need to get a common denominator on our fractions here, so we need to convert this to a fraction first of all, and then get the same denominator. So 7 over 2 stays the same. Then we've got take away. 49 is equal to 49 over 1, but we need it over 2, so we're going to multiply 49 by 2, and that gets us 98, and then it's going to be over 2. And then we just need to take 98 away from 7, which gets us minus 91 over 2. And what form do they want the answer in? It just says work out the value. Okay, so we can just put the answer as minus 91 over 2. So question 20 is worth 2 marks, and we need to solve 3x minus 8 equals 19. So the first thing to do is to plus 8 to both sides, and when we do that, we get 3x on the left hand side equal to 27, and then we need to divide both sides by 3. So to get to the next line, we divide by 3. When we do that, we get x is equal to 9. So that was the final answer, x is equal to 9. So question 21 is all about probability, and it's worth 3 marks. So we are given 5 number cards, as we can see here, and 2 of the 5 cards are picked at random, and we need to work out the probability that the total of the 2 numbers is more than 30. So the first thing to do for this question is to see how many different combinations of the 2 cards that we can get. So let's say we picked 17 as the first card. 17 can be picked with 12, 23, 15 and 16. So that means that for 17 being picked first, there are 1, 2, 3, 4 options. And this is the same for every card. Say if we pick 12 first, we then have the option of picking 17, 23, 15 or 16, 4 options. So for each card, there are 4 different options. And we have 5 cards in total. So we've got 4 options per card, and there are 5 cards, so the total amount of options is 20. The next thing to do is to work out how many of these 20 options give a value more than 30. Now, just from looking at these values, I can see that a lot of them will. So 17 plus 23, 17 plus 15, 17 plus 16, and so on. So what might be easier is to work out which combinations do not give more than 30, because it seems like there's far fewer of them. So let's have a look. Which ones give less than 30. So we could have 12, and then 12 combined with, let's see, 15, 12 combined with 16, and 12 combined with 17. Okay, we can then also have, let's see, I think that's everything actually. That is there, all the combinations that give something less than 30. But we could also pick, I'll just quickly show this, we could also pick 15 first. And then it would be with 12, and then we could also have 16 first with 12, and then we could also have 17 pick first, again with 12. So these are all the combinations in all the possible orders that give less than 30. So that is 6 in total. So there's 3 here, and then there's another 3 here. So it equals 6 less than 30 total. And we've got 20 options. So 20 take away 6 equals 14. So there are 14 which give a combination which is more than 30 total. So therefore the answer is 14 over 20, which give a total of more than 30. So if we cancel this down, we get 7 over 10, which is equal to 0.7. Question 22, part A. We need to complete the table of values for the equation y equals x squared. So essentially what we need to do is the x values up here, sub this into the equation and write down the y value that we get. So when we sub minus 2 into x squared, we get 4 for y, minus 1 gives us 1, 0 gives us 0, 1 gives us 1, and 2 gives us 4. So that is the first part of 22. Question 22b is everyone's favourite question of draw the graph, which is, I know it's not my favourite question at all, far from it. But what we need to do basically is plot the x values with the corresponding y values. Okay, so we've got negative 2, 4, so we go to negative 2 on the x, which is here, and then we go up to 4, which is here, and we're going to plot a point there. We've then got, you know, you've got to be accurate. I think you've got to be within 1 square of accuracy in the actual exam, so make sure you are really accurate with your points. We've then got negative 1, 1, so that's that point. We've then got 0, 0, so this point here. Then got 1, 1, and 2, 4. Okay. Now we need to complete the curve, so we need to draw a line of best fit, so a smooth curve through all these points, which is not very easy. So just do your best, but make sure you go through all the points and have the turning point at 0, 0, and then up like so. And that'll be enough for the, how many marks is this? The 2 marks in the exam. It wants the values of x from minus 2 to 2, as it says up here, so there's no need to carry on like this. You may lose a mark for doing that. But the graph I've done is not perfect, but it'll get you the marks. So question 22c is following on from our graph that we've just plotted of y equals x squared, and we need to use our graph to estimate the value of the square root of 2.6. So our equation for the graph is y equals x squared. We can rearrange this to get square root of y is equal to x. And then if we compare this to what we're being asked in the question, where we've got square root of 2.6, we can say that the square root of 2.6 is equal to some value, which is x. So if we find 2.6 on the y-axis, because we've subbed in 2.6 for y, we can get an estimate of the value of x. So let's find 2.6 on the y. Let's change colour. So if we go to 2.6, that is this point here, and if we go across, we get that value, and we also get this value on the other side. You know what, let me redo that, that was shocking. So 2.6, go across, one value there, and again, go across. So these are our 2 values, and if we then follow them down on both sides, just so that the examiner knows exactly what we're doing, we get negative 1.75 roughly, and actually no, negative 1.7, and then positive 1.7 as well. So we can just put plus or minus 1.7. Question 23, Part A. We are told two consecutive whole numbers are n and n plus 1, and we need to simplify for Part A. N, take away brackets, n plus 1. So what we need to realise is when we've got a negative sign outside the brackets, as we do here, all the signs inside the bracket must change. So the n comes negative and the 1 comes negative as well. So we've got n from outside of the bracket, then we've got our negative n from inside, and then we've got negative 1 from inside as well. Simplifying, the n's cancel out, n to a kn is 0, so we're left with negative 1. So the answer is negative 1. 23, Part B, we need to multiply out n brackets n plus 1. So when we do that, what we have to do is multiply these two terms, and then also multiply these two terms. So when we do that, we get n squared plus n, and that is the final answer, n squared plus n. Okay, so question 23, Part C, we are told that the two numbers are added together and we need to show that the answer must be an odd number. So if we go back to Part A, our two numbers are n and n plus 1. So let's see what happens when we add them together. So we've got n plus 1. This simplifies to get 2n plus 1. Now any number multiplied by 2 will always give an even number, so this is always even, and then if we plus 1 to any even number it will become odd. So we need to just put that in some kind of words for the examiner. So we can say 2n is always even, then therefore plus 1 to 2n will always give an odd number, and that should be enough for 2 marks in the exam. So for question 24, we need to circle the value of cos 30, and we've been given some multiple choice options down here. So cos 30 is a useful trig value to know off the top of your head, along with things such as cos 60, sine 60, so on like that. But if we don't actually know the value off the top of our heads, we can still work this out in the exam. And the way I'd do it is I would draw the cos graph. So I'll quickly just draw this now. So we've got our axes here, and then we start at 1, go down to -1, and we come back up. And I'll just quickly mark some points on this graph as it's not to scale at all. So this is 1, then we've got -1. This point here is 90 degrees, this is 270 degrees, 0 degrees obviously, and then if we go to the very end, this is 360 degrees. So, okay, we need to work out what cos 30 is. So if we plot cos 30 on our graph roughly, if 90 is this point here, we can see that cos 30 is going to be a third of the way between 0 and 90. So cos 30, again not drawn to scale, is about here. You know what, I'm going to quickly redo this part of the graph to make it more obvious what's actually happening. So let me just quickly redraw the axes. So okay, and then the red part goes up like this. Okay, so and this is the point 1 here. So cos 30 is roughly here on our graph, this point here. So we can see that it's less than 1, which is something to know straight away. So we can immediately discount the value of 1 at the end here, so we can say it's not 1. We can then look at our graph again and see, okay, is it 0? And no, it's not 0, because 0 occurs at 90 and 270 degrees, as we can see from our graph again, so we can get rid of 0. Let's leave root 3 over 2 because we're not exactly sure what the precise value of root 3 over 2 is without a calculator. But the value of a half, we can see this in our graph. So we can see that a half is, if we go across from a half and go down, it's much closer to 90 than it is to 0. So we can again discount a half, and we're then left with root 3 over 2, which must be the value of cos 30, and as it turns out, it is the value of cos 30, so root 3 over 2. Question 25 is worth 4 marks, so it's quite a big question, and what we have to do is work out this expression here So we've got two mixed numbers and they're being divided by each other. So it's a fairly straightforward question. We've just got to take it slowly to make sure we don't make any silly mistakes. So the first thing to do is to convert both of our mixed numbers into improper fractions, and the way to do this is we multiply the 8 by the 2, so the whole number by the denominator, and then we add our numerator, which is 1. So we do 8 times 2, that's a terrible 8, do it again. We do 8 times 2 and then plus 1, which leaves us with 17. So we can then say that 8 and 1/2 is equal to 17, and the denominator stays the same, 17 over 2. We'll then do the same for our other fraction. So we do 2 times 3, and then we plus our numerator, so 2 times 3 plus our numerator, so plus 2, and this gives us 8, and we can therefore say 2 and 2/3 is equal to 8 over 3. Let's not rub that out, 8 over 3, as the denominator stays the same again. So we can then rewrite our original question as this. We've got 17 over 2 divided by 8 over 3. So when we've got two fractions that are being divided by each other, what we do is we keep the first one the same, 17 over 2 stays the same. We then change the sign to a multiply and we flip the second fraction, so this becomes 3 over 8. And then when we have two fractions multiplied by each other, all we have to do, very simply, is multiply the two numerators and two denominators together. So when we do that, we are left with 51 on the top over 16, and it wants us to give our answer as a mixed number. So we just need to convert this into a mixed number now. So what we can see is 16 multiplied by 3 gives us 48, and that is as close as we can get to 51 without exceeding it. So we know that we've got 3 wholes, and then if we do 51 take 48, this leaves us with a remainder of 3. So we've then got a remainder of 3 over 16. Right, okay, so question 26, we are told that there's a ship sailing in a straight line from its home port, and we are given a distance time graph which shows 4 hours of the journey. So from our graph we've got distance and we've got time, and of course it goes from 0 hours up to 4 hours. So for the actual question, we need to work out the speed of the ship during these 4 hours. So the first thing to do is to write down an equation which is related to speed, distance and time, and that equation is speed s is equal to distance d divided by time t. So to work out our speed, we therefore need to work out distance and time. So the easy one is time. It's simply 0 to 4 hours, so therefore it is 4 hours. So we can say that that is equal to t. To then work out distance, we need to work out the difference between this point here and the point where our line ends moving across to the y-axis, which is this point here. So let me just make that a bit clear at that point and that point. So to work out these points, we need to know what each individual square is worth in our graph. So we can see between 0 and 20, there's 1, 2, 3, 4, 5 squares. So therefore 20 divided by the 5 squares is equal to 4. So each square is worth 4 miles, okay? So therefore, our point here is going to be equal to 40 plus 2 times 4. So that is equal to 48. So this point is 48 miles. We then do the same for our second point up here, but this time it's 120, take away 1 square, so this leaves us with 116 miles. So the total distance is our highest number, the distance from its home port, take away our initial number, which is 48, the distance it started at hour 0. So we do 116, take away 48, so we can say that D is equal to 116, take away 48, which is equal to, let me see, 68. Is that right? Yep, 68. Okay, so we've now got our time, which is 4 hours, our distance, which is 68 miles. So we can work out our speed. So speed, S, is equal to distance, 68, divided by time, which is 4, and 68 divided by 4 leaves us with 17, and the unit is miles per hour. So 17 miles per hour. So for question 27, we are told that Kim works in an airport in the UK, and she records the number of planes that land between 10 AM and 2 PM each day. So we've got a table here which shows the first 10 days in January, day 1 all the way to 10, and the number of planes she saw on each day. And we are told in part A, the airport was affected by fog on one of these days, and we need to say which day do we think it was, and we need to give a reason. So if we just look at the actual data in the table for number of planes, we can see that there's one day which is far lower than every other day, which is day 8 of 102. So we can say that it's day 8. Then the reason we can say is far fewer planes were seen, and then we can say due to fog, and that'll be enough for the 1 mark for that question. Right, okay, so for part B of question 27, where we're leading on from the data Kim took from number of planes landing per day in an airport, we are told that she's going to use a method to predict how many planes will land in a year. In her method, she uses an estimate of 150 planes, 150 planes in each 4-hour period throughout the day, okay, and she assumes the same number of planes each day. So we've got 150 planes in a 4-hour period. So we need to work out how many 4-hour periods there are in a day first of all. So 24, the number of hours in a day, divided by 4, the 4-hour period, is equal to 6. So there's 6 of these 4-hour periods in a day. And in each of these periods, there's 150 planes. So to work out the amount of planes in a day, we do the 150 multiplied by 6, which gives us 900. What we then do is we need to work out how many planes there are in a year. So we've got the amount per day. So to get the amount in a year, we multiply by 365. However, as this is a non-calculator paper, in the exam they allow a range of values instead of 365. So what we're going to use is 400. We're going to round the number of days in a year up to 400 from 365. So we do our 900 planes per day multiplied by the amount of days in a year, rounded up 400, and this leaves us with 360,000 planes in a day. So the numbers that the mark scheme actually allows, instead of the 400, I'll write them all down. What they allow is, of course, 365. They also allow 336, which is a bit of a weird one. They also allow 364, 366, as well as 370 and our 400. So they're all the numbers that they allow in the exam. I'm kind of surprised that they don't actually allow 350, which is, I don't know, but anyway, these are the numbers they allow. So in the exam, the best thing to do is always to round up to the nearest, say, 100. So 365, of course, goes to 400, and that will give you the full marks as well as any of these alternative numbers. Okay, so for question 27, part C, we are leading on from part A, which was about planes per day at an airport. Moving on to part B, which was estimating the amount of planes that land in a year. And now we are told some new information. So we are told that fewer planes land in winter than in summer, which is, fairly expected, okay. We are also told that fewer planes land at night than during the day, again, as expected, okay. So what does this tell us about Kim's prediction? And we've got to say if her prediction is too low, too high, or it could be too low or too high. So there's 2 points to consider here. So for point 1, where she said there were fewer planes landing in winter than in summer, we need to go back to our original data from our table. So from our table, we are told that this is data for 10 days, which has been taken from, where does it say it? From January. So this is a winter month, and this data is used to influence her prediction in part B for the number of planes in a year, where she's taken an estimate of 150 from this data here. So as that data is from January, and we are told that fewer planes land in winter than in summer, we can say her prediction for part 1 would be too low. So too low. And then we can say as her prediction is from winter data. Okay. Then for part 2, we consider fewer planes land at night than during the day, and from her data we've got the number of planes landing between 10 AM and 2 PM, so this is directly in the middle of the day. So if fewer planes land at night than during the day, and her data was taken from the middle of the day, we can say that her data will be too high, as data taken during the day. So as one of our points says too low and the other says too high, overall we cannot say if her prediction is too low or too high because of these 2 points. So I just put something at the end saying, therefore we cannot say, and that will get you the 2 marks in the exam. Question 28 tells us that the sum of angles in any quadrilateral is 360 degrees. Then it gives an example of a rectangle, and we are told that Zach writes 5 times 90 equals 450 degrees. So the sum of the angles in any pentagon must be 450 degrees. Is he correct? And show working to support your answers. So the formula for degrees in a shape is n minus 2 times 180, where n is the number of sides the shape has. So therefore what we can do is we can write out the formula for a 5-sided shape. So 5 sides, we get 5 take away 2 times 180, so this leaves us with 3 times 180, which is equal to 540 degrees. Put degrees there as well, and in our original formula. So we can say that he's clearly wrong, as he said it'd be 450 degrees, so the answer is no, and then our reasoning is as we've wrote in the this part of the question here. So that would be enough for the 2 marks in the exam as well. Okay, so for question 29, we need to work out the value of a from this expression here. So the first thing to do for this question is to work out the left-hand side of the expression. So to do that, we work out what 6 squared is. So 6 squared is of course equal to 36, and then 8 squared is equal to 64. We're then going to add these two together, so we do 36 plus 64 is equal to 100, and therefore we can say that the square root of 100, where 100 is equal to 6 squared plus 8 squared, is equal to plus or minus 10. Okay, so that's the left hand side worked out. This entire expression is equal to plus or minus 10. So now we're going to move on to the right hand side of the question. this part here. So we can take the cube root of 125 as well as a cubed, all in one step. So the cube root of 125 is equal to 5. Okay, and then the cube root of a cubed is equal to just a. So then what we can say is we can equate our two parts of the original expression together. So we can say that plus or minus 10 is equal to 5a, and therefore we can say that a, and the way I've got to that step, sorry, is by doing our 5 multiplied by our a from within the cube root as they are multiplied in there. So I should actually put another line of work in here saying therefore the cube root of 125a cubed is equal to 5a. And then we move down to this line here where we have 5a is equal to plus or minus 10. So therefore we can say a is equal to 2 or negative 2, so we just put plus or minus 2. So a is equal to plus or minus 2. Question 30, we are getting towards the end of the paper now, so the questions are on the higher level now. At the end of each foundation paper, you do get questions that are also on the higher paper. So this is one of them, and we need to work out the percentage increase, so percentage increase from 80 to 280. So what we do for this question is we take our final value, so the 280, and we subtract our initial value, which was 80, and we divide this by our initial value again, which is 80. So this leaves us with 200 over 80, and then if we cancel down we can divide by 10 to get 20 over 8, which is equal to 10 over 4, which is equal to 5 over 2, which is of course equal to 2.5. So let's say equal to 2.5. So therefore 280 is 2.5 times bigger than 80. Therefore the percentage increase is just going to be 2.5 times 100. So the amount of times bigger, which is 2.5, we multiply this by 100, which gives us 250%. So the answer is 250%. So for question 31, we need to solve this algebraic expression, which is x squared minus x minus 12 equals 0. So as it's a quadratic, meaning we've got an x squared term, what we need to do is write down two brackets and put them equal to 0, as the expression is also equal to 0. Next thing to do is realise that our x squared is positive, so both start of the brackets must be just x, as when they're multiplied they give us x squared. What we then need to do is find two numbers that multiply to give negative 12 and that add to give minus x or minus 1. So all the numbers that multiply to give negative 12 are minus 4 multiplied by 3, 4 multiplied by negative 3. We've then got 6 multiplied by negative 2, negative 6 multiplied by 2, 12 multiplied by negative 1, and negative 12 multiplied by 1. So all of these numbers multiply to give negative 12, but there's only one that will add to give negative 1. So let's start with the top one. Negative 4 plus 3 does give us negative 1, so that's fortunate as it's the first one we've done. So this is the solution that we use, negative 4 and 3. So in our brackets we just put negative 4 and plus 3. Okay, and therefore we need to work out what value of x will give the expression to be 0, as this expression is equal to 0. So let's think about this. If we have if we set x to be 4, this means that in this bracket we would get 4 take away 4, which is 0, and anything multiplied by 0 will always give 0. So therefore we know that one solution is x equals 4. And then for this bracket, if we were to make x equal to negative 3, we'd end up with negative 3 plus 3, which again equals 0. So x, we can say, is equal to negative 3 as well, because again, any number times by a 0 will give 0. So our two solutions are x is equal to 4 and negative 3. And we'll just write this in the answer part, x is equal to 4 and negative 3. Also, what I've done in this step, if it's slightly confusing for you, is basically I've just reversed the sign of the two components in the bracket. So this becomes a 4 and this becomes a negative 3, and those are the answers for x.